Hello lovelies, in this video the brilliant Mr. B is going to be going over Venn diagrams for your A-level maths. Now there are lots of examples here, work through at 3 different levels, and you can jump into this wherever you feel most comfortable and then go forwards and backwards depending on how you feel the revision is going. If you want to see if you can put this sort of question into practice in an exam style situation, then over on my website there are loads of practice and predictive papers that I've written to help you revise.
Diagrams and sets are ways of storing a list of information. Now we can see a few symbols on the diagram in front of us, and the first symbol we're going to look at is this symbol in the top corner. Now this is the symbol for the universal set. So what does that mean? Well, basically it's just all the numbers you can see on the diagram, and this diagram has the numbers 1 to 10. So the members of the universal set are all the numbers from 1 to 10, and you can see all these numbers in the diagram. Now, the question is asking us to list the members of A. Now, we can see A label on the diagram, but what does A mean? Well, A is the contents of the circle next to A. So we can see we've got the 4, the 2, and the 6. And you might be tempted to write 4, 2, and 6 down. But if you continue shading in the rest of the circle, what's going to happen is you're actually going to drift over into this section. It's kind of like an overlap between circle A and circle B. But this is included, so we also need the 5 and the 7. So we'd say the members of set A, and we're just writing all the numbers in set A. So we've got 2, 4, 5, 6, and 7. I've just written them in alphabetical order. You might also be asked for the members of set B. So set B is the second circle, and we shade in the second circle. We can see we've got 1, 9, and 8 inside the circle. So again, they're going to be part of the answer. But if we continue, what's going to happen is you're going to end up in this overlap section again. So what does the overlap section belong to? Does it belong to A or does it belong to B? Well, it belongs to both. So we can colour it in both colours. And we have the members of set B. Then we'd write 1, 5, 7, 8, and 9. So you can see there's an overlap between set A and set B, and they've both got 5 and 7 in. And in fact, the universal set overlaps everything, and so the universal set's got all the numbers in. So you can have a number in more than one set. The last thing you'll notice is that we have 2 numbers that are on the outside. We've got the 10 and we've got the 3. Now, they are not members of set A and they are not members of set B, so they're outside. However, they are members of the universal set, and you will see 3 and 10 in the universal set. Now, all the Venn diagrams I'm going to show you that have 2 circles are going to have the numbers 1 to 10 in. So the universal set, again, the squiggly E, the members of that are all the numbers from 1 to 10. Now, we're being asked for the members of B dash. So what does B dash mean? Well, first, we're going to look at B. So let's highlight set B. So all the numbers inside the circle next to B are parts of set B. That's the 7 and the 6 that are only in set B. And it also includes the 2, the 3, and the 8, which are in the overlap between set A and set B. So 2, 3, and 8, they are in set A, but they're also in set B. So we can say that set B is equal to 2, 3, 7, 2 in alphabetical order actually, let's get 6 next, then 7, and then 8. So what do we mean by B dash? Well, B dash is all the numbers that are not in set B. The dash means not. So if I actually shade this in, it's all of set A is not in set B, apart from the overlap, which is in set B. So it's the kind of the part of set A that's only in set A. Also, the outside section is not in set B as well. Now, where's that relevant is at the bottom, you can see the number 4 is outside of set A and set B. Well, it's not in set B, so we colour it in, and we're going to be including the 4 here. Then for completeness, I'm going to colour around all the outside, but you can see there's no further numbers to highlight. So what's in set B? So we have 1, we have 4, 5, 9, and 10. So these are all the numbers that are not in set B. A big thing to notice here is that you can have overlaps between, say, set A and set B, but you can't have any overlaps between B and B dash. They are mutually exclusive. A number cannot be in both B and not B. On the next diagram, we're looking for the members of A. Then there's a U symbol, and then there's B. So what does this mean? So A, U, B. This means the union of A and B, And what that means is that you want numbers that are in set A or they're in set B. So if I was to colour it in, we've got all of set A, we've got all of set B, and we've got the overlap. So this is what the union gives us. It's the sets combined together. And then with the overlap, you only count the overlap once. We're not writing 6 down twice because it's in A and it's in B. It's only in the blue shaded area once, so we only write it down once. So when we write it out, we write out the numbers. We've got 1, we've got 2, we've got 4, 5, and 6. We've got 8 and 9 and 10. So we've got all the numbers except the 7 and the 3 that are on the outside. So that's the union of set A and set B. Now, alternatively, you might be asked for A and B. And so you can see that the kind of U symbol is upside down. So what does this mean? Well, this is the intersection of A and B. And what this means, you want numbers that are in set A and they are in set B. So what does it mean to be in set A and set B? Well, it's actually talking about the overlap. Now I'm going to do the overlap in both colours because it's also part of the blue section for AUB. We can see the overlap, we have 6 in the overlap. So we want the intersection, want the number that's only in both sets, and that is a 6. So it's very important to remember both of these because they are very common to see. Now, what if we wanted something to represent the 7 and a 3 on the outside? How can we have something to represent these? Well, what you could do is you could look up the opposite. AUB doesn't have 7 or 3, but then if we put the dash next to it, that means not A or B. And so that's going to be the 3 and the 7. So sometimes if there's something you want to find and there isn't a direct way of finding it, you can find the complete opposite thing to it and then put a dash to say not. These are different ways of using the union and intersects. Now, next we want the members of A take away B. So how is this going to work? Well, we're talking about A, so let's have a look at A. So we've got the circle for A. So I'm going to stop colouring the whole thing now, just highlight the outside to save time. And then we've got B, and we've got the circle for B. So you can see it overlaps the circle for A. So let's write down each set. So set A has 1, 3, 6, 7, 8, and 9. Set B has got 1 and 5. So what is set A take away B going to give us? So really all we're going to do is we're going to take away the numbers from one set away from the other set. So we're going to start off with set A because it's A take away B. And if we are taking these away from each other, do we have anything we can take away? Well, set A has got 1 and set B has got 1. So what we can do is we can take the 1 away. But you can see that none of the other numbers match up. So we keep them as they are. So the answer is going to be 3, 5, 6, 7, 8, and 9. So what we're doing is we're keeping all the numbers in set A and set B. What we're not keeping are numbers in the overlap. Now, if I was to colour in what this is giving us on the diagram, it's given us everything that's uniquely in set A, so numbers that are only in set A and nowhere else. Colour these in green. And it's given me numbers that are uniquely in set B. They're only in set B and they're nowhere else. What it's not giving us is it's not giving us this overlapping section with a 1 in it. That's what A take away B means. The next one we'll look at is B take away A, and then we've got brackets and the not symbol. So it's best to do this a step at a time. Start off inside the bracket. Well, let's look at what B minus A is. And then once we've done that, then we can think about what the not symbol is going to mean for us. So B take away A, that's going to be everything that's uniquely in set B. And it's going to be everything that's uniquely in set A. But it's not going to be the overlap. Because we can take 8's in set B, and 8's also in set A. So when we take away, because it's in both, it's going to get cancelled out. So what I've highlighted in blue is our set B take away set A. Now, the next thing we want is we want what's not in those. So let's write in B minus A first. We've got 2, 3, 5, 6, 7, and 9. So if it's not B minus A, it's everything that isn't in the blue shaded area. So it's the white area around the outside, That's not in the blue shaded area. And also, you'll see that the intersection of A and B is also not in the blue shaded area. So we want to have that included as well. And what you'll see is it's all the numbers that weren't in the B minus A list. So that is the 1, the 4, the 8, and the 10. So again, you can see if you've got a set and then not that set, none of the numbers are going to overlap. We've got all 10 numbers here, but they're sorted into the 2 separate lists. And the big thing to do here is, if you've got not something, a helpful thing to do is to find that thing first, in this case B minus A, and then find a not version of it. So do it in 2 steps. Now, there are 2 types of Venn diagrams you might see, and the easy questions were one example where you have multiple numbers inside the diagram and it's representing items in a set. The second type, like this, has single numbers in each section, and this is giving us probabilities. So our first question, we want the probability of getting A. So we look at circle A, and we look at the numbers inside circle A, and we can see there's a 1 that's just in A, and there's a 4 in the intersection of A and B. So we say that the probability of A, so we look inside A first, and we have 5, the 1 plus the 4. Then we want actually all the numbers all together. So for the denominator, we've got a 6, another 6 is 12, a 4 will give us 16, and then the 1 will give us 17. So we're going to write the probability of A is 5 out of 17. The 5 coming from the numbers inside set A, the 1 and the 4, and the 17 coming from all the numbers together. So we have a probability. We could also look at the probability of not getting A. Now, the probability of A and not A are going to add up to give you 17. So what do we add on to 5 to get 17? We're going to add the 12. So you see the probability of A and not A, 5/17 and 12/17, they both add up to give us 17/17. That's another thing you can do with this kind of diagram. Next to the probability of A are U and B. So that's the probability of the union of A and B. And so the union of A and B is going to be all circle A plus all of circle B. So we look at the numbers inside. We've got the 6, the 5, and the 2. So we add those together, which is 13. So then we can say that the probability of the union of A and B, so choose a number at random from there, is going to be 13 over, and again, now we need all the numbers in the diagram. So we've got 6, and 6 is 12, plus 5 is 17, plus 2 is 19. Here we can write now we got it, so it's really clear what all you're working out is. You might also be asked for the intersection. So we might want the probability of A and B. Now, the intersection is just going to be the bit where A and B overlap. And what can we see in there? We can see the 5. So that would be 5 out of 19. So once you actually work at the denominator is usually the same for any kind of question you might be asked on the same diagram. There's some numerators that are going to be different. Also note that the union and the intersection don't add up to give 19 out of 19. In this case, it's 18 out of 19, but there's actually no guarantee that you'll get any particular number with these two. There's no pattern between them. There's only kind of pattern with getting something and not getting something. So, for example, if you wanted the probability of not getting U and B, so you put a dash on this, then that would be 5 out of 19. And that would add up to 19 out of 19. In fact, it wouldn't be a 5, it would be a 6 to add up to 19 out of 19. And what would that represent? That would actually just represent the 6 on the outside, because that's the only thing that's not in the union of A and B. Next, we've got the intersection of not A and B. So it might be helpful to look at these one at a time. So not A is everything outside of circle A. So let's highlight what we've got. We've got the 7, that's outside of circle A, and we've got the 6. Next, we want to highlight B. So we do want things inside of circle B. So we've got the 2, and we've also got the 6. Now, N stands for the intersection. So we want things that are coloured in both colours, and we have something. It was the 6. So you can see, using colour coding, you can quickly figure out what you need to have, basically judged on what's coloured in both colours for the intersection. So we can say the probability of having the intersection of not A and B is equal to, so we have the 6, and then total, we want to add up all the numbers together. So we've got the 7, and the 5 gives us 12, and the 2 gives us 14, and the 6 will give us 20. So we know it's going to be 6 out of 20 chance. So if it looks really complicated, a good strategy is to just do each bit one at a time and then have a look at the kind of thing that combines them together last. Next, we have another intersection question. So we're going to look at A and not B separately. Then we're going to see which one's both, because again, the intersection symbol is for both. So we have A, that's going to be the 5 and the 2. And then we've got not B. So not B is actually going to be the outside of the circle. So what's on the outside? So we've got the 2. Oh, sorry, we don't have the 2, we've got the 5, and we've got the 6. The 2 is inside the circle, so we're not going to have that. So what's coloured in both colours? Well, the 5 is coloured in both colours. So that means the 5's in both parts, so it's in the intersection. So we can say the probability of getting A and the intersection with not B is going to be, so we've got the 5, that's what we want. Now we need all the numbers in total. So we've got the 6, the 5, the 2, and the 6 in the entire thing. 6 plus 5 is 11, plus 2 is 13, and plus 6 is going to give us 19. So it's going to be a 5 out of 19 chance to get something in the intersection of A and not B. Now, the next one's interesting. We've got a line instead. So what does the line mean? So the line and the A, this means given A, given that A has happened. So given that A happened, we're only going to look at the A circle. This is the only thing we'll look at in the entire diagram. This is now the universal set for us. So we don't care about the 3 or the 6. So A's happened. There's nothing we can do about this now. Now we want the probability of not getting B. So we're going to have a look at everything outside of set B. Now set B, it will highlight it. It actually only includes the 7 because we don't care about the outer part of set B. That's part of the diagram that we've discarded. So everything highlighted in pink is set B. And so we've got a 7 in set B. So we want not set B. We actually want the numbers outside of it, and that's only the 3. Again, the other 3 and the 6 we don't care about. So what do we write down for our answer? The probability of getting not B, given that A's happened, is going to be, so we've spotted a 3. The 3 is the only number that's not in set B, given that we've discarded everything that's outside of set A already. What do we have as our denominator? Well, all we have left in the diagram is the 3 and the 7, which gives us 10. It's actually going to be a 3 out of 10 chance. So again, the line means that the thing after it has happened, and so we can discard any probabilities relating to the things outside of that set. So we don't care about anything outside of A, which is a 6 that's only in set B, and the 3 on the outside of both A and B. We do care about the 3 that's in set A on its own, and we care about the 7 that's in the overlap as well. So we just limit our problem just to those 2 numbers. Now, for the hard questions, we'll look at Venn diagrams that have 3 circles. So there's 3 different sets inside the universal set. So the first question, we've got the probability of B happening. So we'll just follow the same things before. We're going to highlight set B. And the probability of B, then we're just looking at the numbers inside set B. So we've got the 6, the 2, and the 1. So you'll see there's more numbers now within set B, but they all represent different things. The 2 is only in set B. The other 2 is in the intersection of all 3 sets. The 1 is the intersection of set B and C, and the 6 is the intersection of set B and A. So we add these together, 2 plus 6 plus 2 plus 1, and altogether that's going to give us 11. So we can say the probability of getting a B is going to be, the numerator is 11. What about the denominator? So we need to look at all the numbers in the diagram. So we've got, let's look at the outside first with the 6. Let's just look at the single set, so the 9, the 2, and the 4. Then look at the intersections of 2, so the 3, the 6, and the 1. Then the intersection of all 3, the 2. So we've got to add all of these together. Might be useful using a calculator just so you don't make any mistakes. Quite a lot of numbers, it's very easy to miss one out. And we get 33. So it's going to be an 11 out of 33 chance. For the next question, what the probability of B, U, C? So that's U for the union. Well, set B and C together. So let's highlight what we're looking at. We're looking at all of set B and all of set C. So it's going to look something like this. We've got quite a lot of numbers inside, so we need to add all of these up. So we've got the 6 and the 5 that's only in set B and C. We have got the 3 and the 8 in the overlap of set B and C. Then we've got 3 and the 1 that overlap into set A. So we need to add all of these up, and it's going to give in total 26. The next thing we need to do is think about what the denominator of our fraction is going to be. We want all the numbers all together. Now you might note you've already added up some of the numbers, so we can do a little shortcut here. We know that all the blue highlighted numbers are 26, so we just need to include the 8 and the 7. So 26 plus 8 plus 7 is going to give us 41. So you can use your previous working out to help with the next step. So altogether, that means that the probability of the union of B and C, if you choose one of these at random, is going to be 26 over 41. Now, the next question, we've got that line again. So the line means the thing after it has happened. So it's given A. So A has happened. The only thing we are looking at in this entire diagram, there's quite a lot of diagram here, but only looking at set A. Only these 4 sets of numbers. We're not looking at anything on the outside of this set. So we're not looking at the 6 or the 7 or the 3 or the 9. We're going to pretend from this point onwards that these don't exist. So for the total numbers in the set, we've got the 4, 7, 3, and 6. So altogether, we've got 20. This is going to be our denominator. Now, what about the numbers we want? So we want the probability of getting a C. So we highlight set C. Again, it's not going to go outside of set A, so it's going to look like this. And we can see 2 numbers inside, the 6 and the 3. So 6 plus 3, of course, is 9. So now we can write down our final answer. The probability of choosing at random something from set C, given that our choice is in set A, is going to be 9 out of 20. The next question, what the union of A and B and C. So the union of A and B and the union of B and C. So it's a union of all 3 together. So the probability of finding something that's in set A, set B, or set C. So it could be anything in any of those 3 circles. And we'll see that almost everything is on the inside of this. So for our numerator, we need to add all of these up. So we've got the 3, the 5, and the 9 that are only in one set. We've got the 4, 6, and 3 that are in 2 sets, and the 8 that's in all 3 sets. So we need to add all of these up. Altogether, that gives us 38. Now we need to know how many numbers there are altogether, and we can see there's only actually one number on the outside of this set, it's 3. So we're going to take the 38 we added up already, add on the 3, and that gives us 41. So the probability of at random choosing something in the union of set A, B, and C is going to be 38 out of 41. So we can see it's a pretty big chance. There's only 3 things that are not inside that giant set. You could also be asked for the intersection of 3 sets. So the probability of getting U, N, B, and C. So for that, you want something that's in the intersection of all 3 sets. That's the 8 right in the middle. And so that would be 8 out of 41. Again, a really important thing here is don't get the union and the intersection mixed up. The union includes everything in all 3 sets, and the intersection is only the thing that's inside all 3 sets. Now, final question. Again, we've got given A has happened. So we're only going to be looking at set A. So anything on the outside of this is now going to be completely irrelevant. So what are we being asked for? We're being asked the probability of the intersection of B and C. So we want where set B and set C cross. Now, normally it would be all of this section that I'm highlighting in green. However, the bit on the outside of the blue circle is outside of set A, and we know that set A has happened. We've chosen something in set A, so we can't go outside. So we're only looking at the bit I've highlighted in green. And we can see there's one number there, there is a 6. So probability of choosing something in the intersection of B and C, given that our choice has to be in set A, is going to be 6 out of, now it's going to be 6 out of the total of what's in set A. So what's in set A? We've got the 5, the 4, and the 2 6s. So we add all of that together, that's going to give us 21. So it's going to be a 6 out of 21 chance of choosing something in the intersection of B and C, given that the choice has to be in set A.